Identify any horizontal or vertical isotopes. When do those occur? Well, let's look and see what the book says. It says y equals b is the horizontal isotope of the graph of a function y equals f of x as x approaches the limit of b as x approaches either positive or negative infinity. So we talked about that the other day. A horizontal isotope occurs when we look at the behavior of x. And there's some cases we'll talk about. A vertical isotope is x equals a number, and that's when the limit approaches positive or negative infinity in the y direction. That's the fancy way of saying that. So we look at this equation here. First thing you want to do is graph it. So let's graph this and see what it looks like. So I'm going to come in here and I'm going to say x divided by the quantity x squared. Now right away, what do you notice about this function? It has x in the denominator of a rational expression, which means some value for x might make the bottom equal 0. If that's the case, then we have a domain restriction. There's probably going to be a vertical isotope. Vertical isotopes occur when we have a 0 in the denominator. Horizontal isotopes occur at the ratio of the leading coefficients. Okay? If they have the same degree, polynomial. So, well, let's look at the graph and then I'll explain it to you. All right, holy moly, there's a whole bunch of them. This is a vertical isotope here, and this is a vertical isotope here. Okay? The reason there's a vertical isotope is that these x values will make this denominator equal 0. There's also a horizontal isotope at 0 because the bottom is a second degree polynomial, the denominator is a second degree polynomial, and the top is a first degree polynomial. So as we approach positive infinity, which one gets bigger quicker? The denominator or the numerator? Well, let's talk about that. So, here's what we need to do. We're going to have to algebraically prove this, and we'll still have to use our calculator too. So, let's write down the equation. The equation is, for example number 10, y is equal to x over x squared minus x minus 2, right? Is that right? Is that what it was? Yeah. Alright. Zoom out. And so now we're looking at the graph. Well, what do you want to do? Horizontal or vertical isotopes first? Let's do the horizontal. So now for horizontal isotopes, what we're looking for is the end behavior. Alright, we're going to study the end behavior. So what we're really doing is we're looking to see what the limit of this thing is as x approaches infinity. Well, think of it like this. We're going to plug in numbers for this equation, okay? So if we're going to plug in numbers for this equation, let's pick out a really big number. Big number. Give me a big number. 4,000. Let's do 10,000. So if I let x equal 10,000, I'm going to have 10,000 on the top, 10,000 squared on the bottom, and really we could ignore the rest of the terms. So what are we going to end up with? 1 over 10,000. And if I plug in 100,000, I end up with 1 over 100,000. And so this will continue to approach some number, and we'll just call that number c, over infinity. If I take a pizza and I slice it up into 4 slices, I have pretty big slices of pizza, right? If I take that same pizza and I slice it up into 8 slices, I have smaller slices of pizza. If I take that same pizza and slice it up into 64 slices, I have very small slices of pizza. If I take a pizza and slice it into infinitely many slices, how big is the slice? it ends up being 0. So the limit of this function as x approaches infinity is going to approach 0 because the bottom is going to be bigger than the top always. So this will be 0. Because I'm going to have a really big number on the top, but because we're squaring the bottom, it's going to approach 0. Does that make sense? Now if I do that in the same direction, I'll have a negative number that approaches 0. So if I were to take, in other words, the limit of this function as x approaches negative infinity is still going to be 0. So what that means is this behavior, y equals 0, is my horizontal asymptote. Does that make sense? Because we're never ever going to get to 0. We'll approach it, but we'll never get to it. It'll never ever equal 0. Now, are you guys ready to do the vertical asymptote? Yes, Mr. Adams. We're almost done. I hear kids in the hallway. You guys are getting excited. So now for the vertical asymptotes, we look at the denominator. The denominator helps us to determine the vertical asymptote. So our denominator was x squared minus x minus 2. Well, that can't equal 0, right? So what numbers or values for x makes that equal 0? I don't know. Let's see. Let's see if we can factor this. If I take x squared and negative 2 and I put an x here and an x here and maybe I put a negative 2 here and a positive 1 there, I get 1x minus 2x. Does that match up? Yes, it does. So I get x minus 2 times x plus 1 cannot equal 0, or x minus 2 cannot equal 0, or x plus 1 cannot equal 0, which gives me x cannot equal 2 and x cannot equal negative 1. Vertical asymptotes right there. Boom.
That was easy.
Any questions? So the horizontal asymptotes, we're just going to look at the graph and see what it approaches going towards infinity. So let's look at what this looks like on the calculator on the graph. So for the horizontal asymptotes, we look at the behavior of the graph as x approaches infinity and we try to understand that. So as we do that, we see that the top blows up or reaches infinity, but the bottom reaches infinity quicker. So we think of it in terms of some constant over infinity, which is really 0. If we approach in the negative direction, if we head towards negative infinity, in other words, we follow the graph this way, the same thing occurs. Even if I put a negative number, a more negative number, and a more negative number, the bottom is also negative. Well, it's positive because it gets squared, but the bottom blows up towards infinity quicker, so it ends up being 0. So my horizontal asymptotes in this case would be 0. Well, if you look at the graph, guess where it never crosses in the horizontal direction? 0. My vertical asymptotes occur when the denominator equals 0, in this particular case, because it's not defined, can't be defined. So that occurs at x equals 2 and x equals negative 1. And we can verify that by hitting trace and plugging in negative 1, and guess what? Not defined. If I plug in 2, not defined, and that's what these vertical lines represent, is the vertical asymptote. If you have a newer calculator, it won't show those vertical lines. But those are the new pretty pink calculators. Okay? Any questions?